Good morning, student. How are you? So yesterday we have discussed about inverse trigonometric function intro with 2-3 example. Today I will discuss with you some more examples of related to exercise 2.1. First is tangent inverse minus 1 by under root 3. So first of all, we have done a property tangent inverse minus theta, that is minus tangent inverse theta. Okay, first we will solve it by using property tan inverse minus theta. We will write it minus tan inverse theta. It means minus tan inverse 1 by under root 3. Now, according to trigonometry table, where tangent 1 by under root 3, you know, at pi by 6, you know, tangent pi by 6 is 1 by under root 3. Now, the next question is, tan inverse and tan cancel or not? First, we will check pi by 6 belongs to principal value branch of tan inverse. So you know principal value branch of tan inverse x is, x belongs to minus pi by 2 to plus pi by 2. Is wrong or right? Wrong. Because in open interval, not in close. So you know pi by 6 belongs to in open interval minus pi by 2 to plus pi by 2. Therefore, tan inverse and tan both cancel each other. Result is minus pi by 6. The answer is minus pi by 6. Is it clear? Okay. Next question. Question number 2. Tangent inverse tangent 9 pi by 8. First of all, you keep in mind, inverse is not the process for direct cancelling. First we will check where theta lies. So you know, in tangent inverse, tan inverse into tangent theta, we know theta should be lies between minus pi by 2 to plus pi by 2. But you know 9 pi by 8. 9 pi by 8. 9 pi by 8. You can solve it also. 9 by 8 into pi by 8 change into 180 by pi. 180 by pi. Okay. So now 1620 by 8. It means 8 to 16, 0, 8 to 16. Okay, so you know 202 degrees something minutes. So that is greater than minus pi by 2 to plus pi by 2. So we will change it tangent inverse into tangent 9 pi by 8. So first you will write 9 pi by 8 not belongs to minus pi by 2 to plus pi by 2. So in next process we will change it into 9 pi by 8 written as pi plus pi by 8. Or you know tangent pi plus theta, tangent pi plus theta in third quadrant. You know in third quadrant 0, pi by 2, pi. After school to college, so pi plus theta, no change. And tangent pi plus theta is tangent theta. tangent pi by 8. Now you can see pi by 8 belongs to minus pi by 2 to plus pi by 2. Now we can cancel each other and answer is pi by 8. Clear? And the third question is, I hope you are doing practice also. Okay. In question number 3, 2 sine inverse 1 by 2 plus 3 tan inverse minus 1 plus 2 cos inverse minus half plus 4 secant inverse under root 2. You will see today where is sine 1 by 2. So according to table, sine pi by 6 is 1 by 2. Here tangent inverse minus theta. We can write it minus tangent inverse theta. But cos inverse minus theta. So cos inverse minus theta is pi minus cos inverse theta. But first you will take 2 as common, and now cos inverse minus theta written as pi minus cos inverse theta. 4 secant inverse under root 2. I will write property. You know cos inverse minus theta is pi minus cos inverse theta. Okay, the next step, 2 sine inverse sine pi by 6 minus 3 tan inverse 1. So where is tangent theta 1? Pi by 4. Tangent pi by 4 plus 2 pi minus 2 cos inverse 1 by 2. Where is cos 1 by 2? Cos pi by 3. Cos pi by 3 plus 4 secant inverse under root 2. So where is secant under root 2? Cos pi by 4 is 1 by under root 2. Therefore secant pi by 4 is under root 2. Therefore you will write secant pi by 4. So you know pi by 6 belongs to the branch of sine inverse, pi by 4 branch of tan inverse, pi by 3 branch of cos inverse, pi by 4 branch of secant inverse. So each will cancel. 2 into pi by 6 cancel, pi by 4 cancel, 2 pi by 3 cancel, 4 into pi by 4. So now 2 3's pi by 6, pi by 3 minus 3 pi by 4 plus 2 pi minus 2 pi by 3 and pi. Now taking LCM and find the exact value of the question number 3. Okay. Now some properties of inverse trigonometric function. First is sine inverse x written as cosecant inverse 1 by x, and same cosecant inverse x as sine inverse 1 by x. Okay, how can, in first part, sine inverse x, we suppose it is y, sine in right side, sine inverse change into sine y, x is equal to sine y. Now we change into cosecant, to taking reciprocal, 1 by x equal to 1 by sine y. You know 1 by sine y written as cosecant y. and cosecant change into cosecant inverse 1 by x. Okay, so y is equal to cosecant inverse 1 by x and y is equal to sine inverse x. It means both are equal. You can write sine inverse x is cosecant inverse 1 by x. So similarly, another properties also we will verify and you can do yourself. Cos inverse x is secant inverse 1 by x and secant inverse x is cos inverse 1 by x. Tangent inverse x is cot inverse 1 by x. Cot inverse x is tangent inverse 1 by x. Okay, so you keep in mind these 6 property. Next is sine inverse x plus cos inverse x is pi by 2. Sine inverse x plus cos inverse x is pi by 2. So how will you prove it? Okay, so we'll change it. Let sine inverse x is y. Sine in right side will change. Sine inverse change into sine y. Or you know sine theta written as cos pi by 2 minus theta. Cos convert into cos inverse x. Here pi by 2 minus y. Minus y change into plus y. Y plus cos inverse x is pi by 2. Or you know y. What is y? Sine inverse x. So thus sine inverse x plus cos inverse x is pi by 2. So first property, sine inverse x plus cos inverse x is pi by 2. For proving it, we suppose sine inverse x as y, then x is sine y. Sine theta written as cos pi by 2 minus theta. Cos in left change into cos inverse x, pi by 2 minus y. Minus y change into plus y plus cos inverse x is pi by 2 and the value of y is sine inverse x. So that sine inverse x plus cos inverse x is pi by 2. Similarly, next property you can prove also. Tan inverse x plus cot inverse x is pi by 2. Secant inverse x plus cosecant inverse x is also pi by 2. So these 3 property you can make into 6. For example, sine inverse x can be written as pi by 2 minus cos inverse x. Tan inverse x written as pi by 2 minus cot inverse x. Secant inverse x written as pi by 2 minus cosecant inverse x. Similarly, cot also pi by 2 minus tangent. Cosecant inverse x is also pi by 2 minus secant inverse x. Next is most important property. Board always give a question behalf on this property. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Tan inverse x plus tan inverse y is equal to tangent inverse x plus y upon 1 minus xy. Let me prove it. Tan inverse x suppose as A, where tan inverse y suppose as B. Here value of x tangent A, value of y tangent B. We have x is equal to tangent A, y is equal to tangent B. Now in class plus 1, we have a property tangent A plus B. Tangent A plus B. So that is tangent A plus tangent B upon 1 minus tangent A tangent B. So you know what is tangent A? X, tangent B y, 1 minus xy. Here tangent A plus B. If we take transpose of tangent, then transpose of tangent convert into tangent inverse. Then A plus B is tangent inverse x plus y upon 1 minus xy. Now what is A? Tan inverse x plus what is B? Here tan inverse y. Now we have a property tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Okay, so on the behalf of this property, we make some rule also. Here 1 minus xy is greater than 0. 1 minus xy is greater than 0. So we will subtract one both sides. Minus xy it means minus xy is greater than minus 1. Multiply both sides by minus 1. Minus minus plus, but sign of inequality change. It means tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, and xy is less than 1. Xy is less than 1. Now same for difference, or you can say minus tan inverse x minus tan inverse y, that is tan inverse x minus y upon 1 plus xy. In the same condition, 1 plus xy is greater than 0, it means xy is greater than minus 1. Next property, 2 tan inverse x. 2 tan inverse x. That is tangent inverse 2x upon 1 minus x square. 2 tan inverse x is tangent inverse 2x upon 1 minus x square. For proving it, taking left, let 2 tan inverse x is equal to y. Okay, 2 tan inverse x is equal to y, and you know tan inverse x is y by 2, and tangent change into tangent y by 2. X is equal to tangent y by 2. So in class plus 1 you have done a property in which tangent 2 theta, you know, tangent 2 theta is 2 tangent theta upon 1 minus tangent square theta. Tangent 2 theta is 2 tangent theta upon 1 minus tangent square theta. And tangent convert into tangent inverse. 2 tangent theta upon 1 minus tangent square theta. And we suppose 2 theta is equal to tan inverse 2 tan theta by 1 minus tan square theta. So according this property or a formula, so we can change this part in theta also. So we suppose tangent inverse x as theta, then value of x is tangent theta. Now you can put theta as tan inverse x and tangent theta as x, 2x upon 1 minus x square. We have property 2 tan inverse x is tangent inverse 2x upon 1 minus x square. Next video, you know some questions in class +1 you have done. Sin theta. Sin theta can be written as 2 sin theta by 2 cos theta by 2. 1 minus cos theta written as 2 sin square theta by 2. 1 plus cos theta as 2 cos square theta by 2. 1 plus cos theta is 2 cos square theta by 2. And similarly, if we have only 1 plus sin theta, so first you will change sin as cos. Sin theta written as cos pi by 2 minus theta. Okay. So now we will apply property 1 plus cos theta is 2 cos square theta by 2. Similarly, if we have 1 minus sin theta, we will write it 1 minus sin written as cos pi by 2 minus theta. And 1 minus cos theta is 2 sin square theta by 2. Okay. Now some pattern you should keep in mind. Some pattern, or you can say property. If we have a square minus x square in square root, then we will put x is equal to either a sin theta or cos theta. But if we have x square minus a square, x square minus a square, then we will put x is a secant theta or a cosecant theta. But if we have a square plus x square, a square plus x square, then x is equal to a tangent theta or x is equal to a cot theta. A tangent theta or a cot theta. Next bit, if we have 1 minus x upon 1 plus x, in such condition you will put x is equal to cos 2 theta. X is equal to cos 2 theta. So 3, 4, first, second, third, fourth, you should keep in mind. Okay, you can cram it according to given radicals form. You should put according to proving. You will check what is right side, then we will put left or right according to we will prove it. X a sin theta or a cos theta. So we will discuss when we will do such type example or question. Okay.